A straight line graph represents a function of the form f of x equal to mx plus c. If we were to draw any function with this form, no matter the values of m and c, it would look like a straight line. What's special about a straight line? Well, the nice thing about them is the steepness of them is the same along the whole line. Its gradient doesn't change. And all we can possibly know about a straight line is 1, how steep it is, its gradient, and 2, whereabout on the graph it appears. First, consider the line y is equal to mx, just ignoring the c for now, or setting it to 0. We want to find out the gradient, or in other words, we want to know how much does the y-coordinate change when the x-coordinate changes by 1. We can figure this out generally. If we go to an x-coordinate on this line, call it x1, we know the y-coordinate will be m times x1. We then want to see what happens when x changes by 1. So this time, the x-coordinate will be x1 plus 1. To find the new y-coordinate, we must again multiply the new x-coordinate by m, and so we get m times x1 plus 1, which gives us mx1 plus m. We can see that this is greater than the original y-coordinate by m. We have therefore figured out that for every 1 that x increases, y increases by m, and so m is the gradient of the straight line. Now let's introduce the plus c into our expression. When we add this on, we are simply increasing the y-coordinate of every point by that amount. In other words, we are shifting the graph upwards by an amount c. Now notice that on our line, when x equals 0, all that is left in the equation is y is equal to c. This means that we can interpret c as the y-coordinate when x is equal to 0. In other words, c is the y-intercept, since the y-axis is defined as when x is equal to 0. So m tells us the gradient of the graph, how much y changes for every 1 that x changes, and c tells us the y-intercept, the y value when x is equal to 0. Clearly there are many straight lines we can draw, but we are often interested when two lines are parallel or perpendicular. What does it mean for two lines to be parallel? It means that they must not ever cross each other, and the only way that this is possible is if they have the same gradient. What does it mean for two lines to be perpendicular? It means that when they do cross, they cross at 90 degrees to each other, at a right angle. Here we have two perpendicular lines. Notice that when we rotate them both, they stay at right angles to each other. At this position here, one line has a steep positive gradient and the other a shallow negative one. Here, one has a medium positive gradient and the other one has a medium negative gradient. And in this position, you can see that one has the steep negative gradient and the other one a shallow positive one. What relationship can we find between the gradient of one line and the gradient of the other? The answer is that the gradient of one is the negative reciprocal of the other. This means that you must take 1 over the gradient of the first line and then make it negative. Take some time to convince yourself that this satisfies the relationships that we found. So for two lines to be parallel, they must have the same value of m, and for two to be perpendicular, their m values must be the negative reciprocal of each other's. If we are given 2 points and told that they lie on a straight line, we can find out everything about the line using those coordinates. Remember, all we can know about a straight line are the values of m and c. We look at these 2 points here and see that the y-coordinate has changed by an amount delta y is equal to y2 minus y1, and the x-coordinate by an amount delta x is equal to x2 minus x1. So we know that for every delta x we go across, we go delta y up. If we were to take the gradient m, which is the amount that y would increase if we increased x by 1, and multiply it by the amount that x has actually increased, what we should get is the amount that y has actually increased. Therefore, we write that m times x2 minus x1 equals y2 minus y1. And we rearrange to get m, the gradient, is equal to y2 minus y1 over x2 minus x1, just the change in y over the change in x. We know that every point on this line satisfies the equation y-coordinate is equal to m times the x-coordinate plus c, with us now knowing m. All we need to do to find c is input the coordinates of one of our points into this equation with our value of m and see what value c needs to take to make the equation work. For example, if we knew the gradient was 2 and that the point 1, 4 lies on the line, we sub in 4 is equal to 2 times 1 plus c, and we find that c must be 2. If we do have 2 points on a line, it can be useful to find out the distance between them and their midpoint. To find the distance between them, we use Pythagoras' theorem. As when we found the gradient, we can work out the change in x and the change in y between these 2 points, and note these lengths down. We see that the length L forms the final side of a right-angled triangle, and so we just sub into Pythagoras' equation to get L squared is equal to the change in x squared plus the change in y squared. The midpoint will lie halfway between these 2 points in both the x and the y directions. Therefore, we find the midpoint of the x and y coordinates separately and set these as the midpoint x and y coordinates. The midpoint of 2 coordinates is just their average, so we just add them together and divide by 2. Therefore, the midpoint has coordinates of x1 plus x2 over 2 and y1 plus y2 all over 2.